Good morning. God morgen, alle sammen. Then you can find your seats. So it's a chilly late September morning here in Oslo. It's Friday, and how can it possibly be a better way to start the day than being here with us at Jungs? Of course, you who are following the live stream did the next best thing, but we hope to see you here next year. Welcome to the second day of GACO 2022. Yay! I'm Sarah, and I'm honored to guide you through a new day with new learnings and even the first ever GACO Awards. So I'll start with a warm-up exercise. In other words, our beautiful list of partners. Our co-presenters are NFI, Norsk Filminstitutt, and Soundly. Our sponsors are Raw Fury, Viken Filmsenter, Elias, and Chaotica Eyeball. Yesterday, Chaotica Eyeball had some giveaways. They are having that today as well. So stay here. And our supporters are Funcom, Hyper Games, Snowcastle Games, Sony Music, Nopa, Virke, D-Pad Studio, Krillbite Studio, Megapop, Knock Knock Audio, Black Cloak Productions, Nonida, SSMG, Norsk Komponistforening, and Media Sound Hamburg. Thank you very much. And now I'm warmed up. Okay. A couple more things. Remember to use your breaks well. Eat, drink, get some fresh air, talk to each other. And after each speaker, we have a Q&A. And today it's going to be a little different than yesterday, so that Chris doesn't have to run around with the microphone. We have a microphone over here, so you can actually just get up there if you have a question. And just ask the question from there. So, take the stage over there. Are you ready to get started? Yes. Hi. I must say, I love the composition of this conference. The overall theme for GACO 2022 is future. And we started out yesterday with a focus on how we as individuals can build and maintain our lives and careers for the future in the best possible way in a challenging industry. Take care of ourselves to last, finding fulfillment, avoiding burnout, and use an altruistic approach and mindset when it comes to necessary tasks such as networking. We saw how crises like lockdown can lead to new ways of working together in an open world, for example, in voice acting. And we got eye-openers when it comes to how excluding games actually are at the moment for visually impaired, and how challenging it can be to compose music based on a culture you're not from, while wearing your own culture's colored glasses. We were given great tools and advice for the future on all of these topics and more. And today we're going to get more eye-openers and fill our toolboxes even more. We'll hear about everything from how herd calls can start careers to generative machine learning, and much in between, areas that I, as a pure music industry soul, can't really get a grip of yet, such as, for example, visual scripting. In the 90s, there was a young man studying electroacoustics in Vancouver, Canada. At university, he started to learn about visual scripting. He achieved an honors degree in computer science and later a master's degree in game audio. Now a coder, composer, and sound designer for 20+ years, Leonard Paul is our first speaker on stage today. He also runs the online school of video game audio and has worked with students from over 60 countries. Leonard used visual scripting style programs for 2 of the major documentary films he's worked on. Audio Mulch for the Canadian documentary The Corporation, and Pure Data for Beep, a documentary history of game sound. And with the growth of visual scripting in Unity, as well as with meta sounds in Unreal Engine 5, in his talk, Leonard takes a close look at what seems to be working well and not so well. How are the systems used in practice? Please give it up from Canada, Leonard Paul.
Great. Thanks. Okay, all right. Yeah, that's an amazing introduction. Thanks so much. And thanks, everybody, for coming. I know that it's early. For me, gosh, what is it? It's 2 o'clock in the morning. So, yeah, I'm getting there. Yeah, so I started in the industry a while ago, and basically I'm interested in showing you sort of like the power of visual scripting and the reason why game systems use them for audio. So yeah, I'm hoping that we'll have a little bit of back and forth. I'm going to show some demos. So I guess that's a bit of a disclaimer that my computer, even though it's all nice and flashy, Mac, that it might have a hard time, especially with Unreal. So yeah, we'll see how things go. All right, so I guess we're okay for the for presentation visuals, or almost. Hey, there we go. Bam. All right, cool. So yeah, there's the title, and here we are at GACO, and that's me at the bottom. There's the school. So yeah, let's just get started. And so I wanted to show this slide at the beginning because, okay, like a show of hands, how many people look at this and feel like slightly nauseous? Like, yeah, a few, all right. Yeah, and I see some nods. No, I mean, the arms are like, not quite there yet. But yeah, there's a lot of density to that, and I understand that, but also I'm going to show you, hopefully, so that you get an idea of that actually, when it comes down to it, this is kind of pretty. Like, it'll make some nice sounds eventually. Maybe not this particular patch, but I'll show you some stuff. So I'll start out with just some examples, a bit of history, some advantages and some challenges to visual scripting, and then the theme, the future. All right? Because that's where we all will live, is in the future. So for me, I started out in 1991, so that's a while ago. Back, I was doing electroacoustics and also a computer science degree. And yeah, I basically knew that, I love music, as I'm sure many people do in the audience, but I also wanted to sort of stretch the possibilities of what I could do with music. And computers were a great way to do that. And I just sort of learned more about the language of music at the same time that I learned computing. And within the comp sci side of things, I learned a lot of stuff I didn't really want to learn. Not all of it was fun. And same thing for on the music side, but more so, I did it so that I could survive. So that's one thing that I know I've talked to a few people sort of separately and just saying, if you're learning a little bit of coding in game audio, it's really helpful. So hopefully this talk will also give you a little nudge towards that as well. It's not so scary. All right, so say in comparison to the first slide that we saw, are people kind of do you kind of understand what maybe is going on here? Maybe some hands? Yes, no? Not yet? Okay, all right, that's good. So basically, I'll just say that this cycle thing makes an oscillator. So in other words, like a sine tone at 1,000 hertz. So 1 kilohertz, it goes through a fader here, and then it goes out the digital audio converter. And then you can stop and start it. This here is max. So that got started way back. It had its origins in 1985. And then what I use these days is pure data. So this is, it's just slightly different. So this is oscillator. And then same thing, and it's the same. And then just multiplies it out, that's the volume, and then it goes out the DAC as well. And then to turn it off and on, you use that. So you can see that, well, I guess that's also another thing too. I won't do a show of hands for that, your arms are gonna get tired. But anyways, I started out with pure data sort of in the mid-90s, and I don't know, I guess, I was gonna say I haven't looked back, but I'm looking back right now. Anyways. Okay, so since 2001, I started doing education over in Vancouver, Canada. And what I did in 2003 is I wrote an article for Gamma Sutra. It's not called that anymore. It's called Game Developer Magazine. And so what I did with my students is that this was this was like back in the day before WISE, right? WISE is Canadian, actually. It's from Audio Kinetic. And it was before, like, I think it was even before, like, Unity, before, well, I mean, Unreal, arguably, maybe. But, like, it was before audio middleware, basically. So there was an engine called Miles Sound Engine back in those days. But the problem for me as an educator is that I had nothing that I could teach my students with unless I was going to teach them, like, C coding or C++. So what I wanted to do with stuff like this is make it so that they could play around with tables and stuff like that, load in samples, and they could do things like make a crowd engine. So the crowd engine, we've got like the low intensity, medium intensity, and it says high. I know that it's tricky with this projector, but it does say high. And then we can also do pitch as well. So that means that, you know, here's the low intensity, and then the pitch goes up, you know, as the intensity rises. It's a little bit weird. You don't want to make the pitch go too high because then they sound like chipmunks, right? So this is sort of a basic crowd model, is that you have, see, this is like the low, that's the crossfade there. As the intensity moves this way, you take out more of the low crowd, the like, ah, and then you go more to the middle, right, ah, and then you go to the high, like, you know, like, woo-woo, at the top there. So I thought that this would be a nice way to work with students and show them that they could do this kind of implementation stuff using, I mean, I had to use the tool. I didn't have to use pure data necessarily, but I thought that this was a great way of like not using code. So for me, one of the ways of visualizing it is that you've got like the low level sort of C code, that's like the driver code, that's what sort of talks to the hardware directly. On top of that, you've got the game code, and then on top of that, you've got sort of the scripting stuff, and that's sort of like what this is, so visual scripting, that's what pure data is, and also Max MSP and other things that we'll see. And then on top of scripting, we've got like implementation, like WISE, so it's kind of like a mixer where you can like change the levels and stuff and do like random containers. And then on top of that, you've got like content stuff, like your samples and stuff that you put into there. So yeah, with that engine back in 2001, but it was published in 2003, I showed like different little methods on how to do basic adaptive music, sound effects, crowd engine, that's here, and stitch speech, which is sort of, in Electronic Arts Canada, we do a lot of sports titles, so like NHL and stuff like that. And so stitch speech is when you've got like so-and-so shoots, they score, right? Like there are different chunks that all get stuck together. And sometimes not very good, like if you've ever done the telephone thing, and it's just like, you're in order number 2, 2, 1. You know, it's just like, oh man, they're never going to answer. So bad stitch speech is not a good thing, and they're still working on it. That's still an open topic to try and figure out how to get that to work better. So yeah, I taught that back in those days. Okay, and yeah, with some sort of examples of my work, like with my introduction that I was given, it was great. This is a patch. It's not a patch, but this is more, it's not actual scripting, but it really looks sort of like pure data. This is audio mulch, and this is how I did the score for the corporation. So I used this, and then more recently, I did the Beep documentary using PD, and I'll show you a piece out of that directly, and so we can listen to it. And I know I'm reading this backwards, but anyways, that's the way it's working. And then the reason why I like using this system is because I can basically jam with them live. Like, I like the idea of being able to work within film and be able to dynamically change the length. So I can change my hit points of where I want sort of action to happen and things to react, you know, to. And that's exactly the same as working with video games, right? You have an action and you want to have like a, I don't know, a stinger, you know, whatever. Cymbal crash is the typical one, right? And so I can do the same thing with this. And if you're interested, you can also check out, I did a talk at Stanford talking about SimCell, which is another video game that I worked on. With that one, I did in Pure Data. So once again, unfortunately, it literally is a blur over here. That's fine. But yeah, like one of the neat things is that every playback is different. So I can combine samples, effects, and synthesizers together to make the sound. So the advantage of this is that, yeah, you use low disk space and RAM space, so low space in memory, but the one of the disadvantages is that you can use a lot of CPU, so a lot of processing, because you're rendering all that stuff live, sometimes. So back, I guess, let's see here. Oh, that'll go on a demo. Back, I guess it was 2016 or so, the lead coder for Grand Theft Auto 5, people know that game? So although this stuff looks super abstract and weird, when you play Grand Theft Auto 5, you don't see this. You don't, like, but you actually hear this. And I'll show you how they did it. They used a different system. They didn't use Pure Data. They used another system called AMP. And yeah, with that, it allowed them to put in a bunch of synthesis stuff that actually was lower CPU than decompressing the files, which sounds weird. So at any point in the game, apparently they had about 70% of their sounds that actually use synthesis. So a lot of the AC, like the air conditioners, and a lot of like noise-based stuff was actually synthesis. But that is a highly realistic, you know, like game. You don't listen to it and hear synthesis, but there's a lot that they sort of, in a sense, snuck in there. So yeah, let's have a look at how this actually works. All right. How do I move over here? Okay, so I got to load this up in Unity. Come on, Unity Hub. Where are you? There we go. Okay, great. All right. So yes, thanks, Unity. All right, we'll load this up. And so with this, this project is actually, oh no, I already opened it? Okay, let me see here. So I'll just switch over to that. Oh, look at that. I think what I did is that I double-clicked it, and it got slightly confused. So the nice thing about this is that things like really busy over there. So that I know it's a yeah, that we could synthesize that actually. That if you want, you can download this whole program on the school's website. It's right at the top. So I've had this available for a few years. And what I've done here is that all the sounds are done with synthesis. And just so you understand, you're like, yeah, but I just like recording stuff and whatnot. That's fine too. You can use samples and synthesis together. I just happen to use this as like a bit of a tour de force, like, you know, just as examples, right? So here we've got, have most people used Unity? I hope? Yeah? Okay, nods. Okay, cool. All right, so this is a game engine. You can build your games in here. And here's the main window. And what I need to do, it's going to be really hard to read, but I'm going to load in the PD patch. So if I go over to here, I'm going to go PD. I'll load that up. So this is not really the way it gets done in industry. What I'm going to do is that I'm going to run Pure Data in parallel to the game, and then it communicates back and forth, so it's bidirectional, with the audio in Pure Data using open sound control. So it's just a way to have them talk with each other. All right. So tanks, there we go. All right, so I am sorry if that's difficult to read. I guess I can, ooh, yeah, right. Thank you, Mac. I can zoom in. So that makes it a little bit easier to read. So what I've got here is I've got sound effects, and then there's music, and yeah, and then I've got a little mixer down there, okay? So this should, if everything goes well, will talk in real time, you know, as we're playing the game, and it'll render the sound. It'll play the sound out of Pure Data. So let's see here. All right. Okay, it's playing out of here. I don't know if it's, let me go to system preferences and move it over. Headphone port, no. Is that's, okay. Go like that, and then maybe go out there. Okay, so hopefully that'll play out the speakers. Sorry about that. I can hear it at here. Maybe what I should do is I'll load PD up again here. This is the lovely thing about doing demos, is that you never know what's going to happen. Okay, so it defaulted to the speakers. No. Okay, so just be careful. So I'm going to switch over to the headphone output. So there we go. Apply. Go OK. Yeah, there we go. Hey, so now you can hear it, right? Not just me. I've heard this before, so a few times. Okay, so we can hear that there's a bit of music playing out, right? And if we look at the game, see, we can see that it's bi-directional, so that I'm actually rendering, like playing the music, and the tanks react to the bass, which is kind of fun. So if I move the tanks around, once again, all the sounds are synthesis, so oops, okay. And then if I hit the other tank with a missile, yeah, I know. When I was playing this earlier, I couldn't hit the tank. So, and now you can hear that the music's faster, right? So the music reacts as any good game would, you know, and the underscore changes, right? And so, move closer again, and I'll try not to destroy the tank. So all of these sounds, like if I run into things like the other tank, you know, you can hear that. Sounds pretty metallic, right? If I go over here, you know, there's a building. I like running into this thing. All right? So that's all synthesis, okay? And, okay. So let's make the music a little bit faster. Okay. I don't want to, no, it's going to be, okay. Okay, see? So that's faster again. All right, so let's switch over to pure data. And I can go into the music side of things. So once again, you know, it does, unfortunately, you know, it has to be dense, because what I've done is I've tried to show you everything here. There's not really a lot that's hidden behind things, okay? So this here is the baseline, and I can change it at the same time while the game is playing. So if I take out like a couple lines here, you hear how that changes the music, right? And so this is sort of where we want to, well, anyways, where I want to, and hopefully I want to get to with game audio, where you can be playing the game and, like, in a sense, jamming with it. Like, I'm a composer and, like, performer, musician type, and I like playing stuff live. And so that's the great thing about scripting, is that that's the difference between, like, coding that usually needs to be compiled, whereas scripting, it can work in real time. So you can, like, play with it in real time and be like, oh, okay, yeah, I want to actually have that more, you know, more stuff going on there, and then add that, you know, layer back in, or I don't know, maybe, I mean, there's other things that I can change as well, but yeah, hopefully, does this sort of make a little bit of sense about what I'm trying to get at with scripting? Is that, yeah, the advantage is that you can change it as the game's playing, right? Whereas that's more difficult to do with code. And the thing that I like with visual stuff is that I can just look at it and change it rather than having to change a bunch of Python stuff, which is also possible, but you know, it's just a different way of sort of approaching the same thing, okay? So there's the music side of things, and if I wanted to, I could also look into the sound effects, right? So if you remember, when I hit that radar tower, I can look in there, and I can basically also test this while the game's playing as well. So, you know, it makes that metallic sound. Oops, there we go. You know, so every time that sound triggers, can you hear it's a little different? Because what I'm doing is I'm basically putting Sorry about for the camera. But anyways, I'm putting noise. I guess I could use the actual pointer, but I'm using noise. And then from there, I'm basically, this is an envelope, and then I'm putting it in through a delay line. And that's the reason why it sounds metallic, is that I put it through a very short delay line, right? So it gives the feeling like you're basically injecting noise into a piece of metal, and the metal is resonating. So that's what's happening there. And I put all that also all through, I believe, a reverb slower down. Okay, yeah, so it goes through like literally a plate reverb. What's a plate reverb? It's a piece of metal. Ah, perfect. So yeah, these are some of course I'm showing some, chosen examples on things that work well. But yeah, like this is kind of where I feel like we want to get to. And hopefully, I know that, there's all sorts of lines and boxes and stuff, and I've left this patch messy because that's how I work. I'm kind of like, I throw boxes and lines down and just see what happens, or listen to what happens. And I've gotten to the point where I can just sort of like improvise. Okay? So, okay. Let's go back to the presentation. And if I shut this, if I shut the game down, the music will continue playing, just with the way that I've done it. So the game is stopped, but on the PD side, it's still playing because it's totally separate. It's not communicating anymore. The game is ignoring it. It's not sending it any more messages, so it's very happy to continue playing. All right, so I do not want to save the changes. Okay, great. Let's zoom back out again. So yeah, there's a little demo at the beginning here. I should check my time here, see how I'm doing. Okay, all right, that's actually a good place to be. So hopefully the demo gives a little bit more engagement as to like WTF this stuff all is, right? Because yeah, it's dense, but also like it's unfortunately, it needs to happen that way to be interesting. So once again, I talked to a few people, I guess yesterday, and even the day before, talking about visual scripting, and I've asked people also with coding why they stop sort of coding if they've tried learning it. And a large part of it is that when you're starting out, similar to like learning music, scales, boring, right? And that's not music, but you kind of need to learn a little bit of structure to get to the point where you can improvise. You can't just start as a jazz musician. I mean, I guess you can, but then, I don't know, you'd have to be super gifted. But yeah, that doesn't happen for most people. Most people, you gotta learn the boring stuff first. So I'm just saying, if you haven't necessarily gotten over the hump of like, doing visual scripting yet, it can still happen. All right, so I'm going to zoom through this next stuff because I want to get to more demos, basically, but I did want to provide some structure as far as background. Way back apparently in 1963, there was a Sketchpad thing that did visual scripting. Then this is 1968, this is Grail. They used a light pen, and you could write on the screen, which is kind of cute. And you could actually make these boxes and stuff, and you can see this kind of looks like PD a little bit. Boxes and then lines between them. And that was like a long time ago. And then, yeah, like when I was sort of starting out teaching back in, over 20 years ago, at Electronic Arts, where I did work. I worked there and started working there as a student, an intern, like in '94 on, I guess, the first NBA Live for the Sega Genesis. And then years after that, we were using AIMS, so I'll go into more detail there. And then there's Scratch. Scratch is that's a little visual scripting programming language for elementary/high school students to learn basic coding. And then in 2008, there was Frostbite got started at Electronic Arts. And this is not meant to be comprehensive. I'm just sort of showing it primarily from my perspective. So if you know of other ones, I'd love to hear from you later, like, over beers, I guess. Or, because there's lots of, it's the same thing as other languages. There's lots of different variations. And then I saw a talk with Guerrilla Games. They did visual scripting, and then Rockstar's AMP that I had brought up before. So EA's audio event management system, they used this in the past, and you can see, once again, it kind of looks like Pure Data / Reactor, kind of like Max MSP. And so this is actually used in those games, like, whatever, sort of in the early 2000s. Okay? And this is an actual patch from the Simpsons game. Okay? Scratch, this is designed for kids, and they have a great large project library, so kids kind of like jam in this. And, man, okay, I'm going to zoom in on this because it's actually kind of interesting. I'll just try to go over the details. It's almost legible. Okay, so, and I need the key over here. Okay, so with this, this is visual scripting as well. So when you hit the space, when space key pressed, start sound. Hey, sound, that's us, right? So you can do audio stuff in Scratch. And then this is a loop, like it says over there, orange control. Do this 10 times, change by X by 10. So our little bird here, the Y, that goes up, all right? And then after that, repeat 10 times, change -10. That means then the bird comes back down again. So basically, this means when the space bar is pressed, it'll make a little chirp sound. It'll go up and then back down. That's like a game mechanic, right? And this is exactly the same thing that happens in, aesthetically, it's a little bit different than Dead Space. But it's exactly the same thing that happens, It really is. It's just, once again, it's colorful. It can make basic games and has audio in it. But even this is very powerful. You can create some amazing stuff in it. This is what Guerrilla Games used for Killzone Shadowfall. They presented it at the Game Developer Conference in 2014. They built this one for performance. Just going to skim over this. Here's Frostbite. So like I was saying, they use this in Dead Space. And from the school, there's a student working with this stuff, which is neat. And once again, boxes and then like lines. And so they've developed this system over years, and it's quite powerful. It allows they call them, the sound designers are audio artists, and they use this system to create like a naturalistic breathing cycle. So when the character runs, really like exerts themselves, then the breathing is going to be like, accelerated and more labored, right? And then over time it goes down. And as a sound designer, a technical sound designer, you're responsible for that behavior, okay? So the visual scripting stuff, they do it that way because it's sort of the easiest way to do it. I did sort of talk a little bit about this. This was used in GTA game audio, and they used it in other titles as well. So, like I said, apparently they used a lot of sounds in GTA used synthesis, which I think is kind of cool. Let's listen to this piece here, which is from the Beep documentary. Once again, I'm trying to acclimatize you a little bit to like these boxes and like lines and stuff. And to me, a part of visual scripting is I'm actually able to sort of tune out a lot of that stuff, and I'm able to focus in on what's important for me. So I do know that it's messy. It's part of, maybe it's my aesthetic, I guess, but hopefully we'll get a little bit more comfortable to that over time. All right, so here's the patch, and let me see, I probably need to set the audio correctly again. Audio settings, external headphones, apply, okay. Okay, so we can hear that, yeah? Okay, cool. Let's zoom in on here. Okay. Are you able to hear it, or? Okay. right, so the way this is working is that it moves through different sort of mix scenes, and it brings in different layers from time to time. And once again, I mean, I could get rid of all these lines, but you know, I'm used to them at this point. And I know that the percussion, say, is on this channel. So, you know, as I'm working on it, I can mute things out. And this track happens to be all synthesis as well, right? And I actually, I was contracted by Microsoft to do some work with the HoloLens. And so the HoloLens is basically a MR, like mixed reality. You can see sort of this projected display thing over, you know, regular life, like through the glasses. And it all runs on a computer that's like, you know, mounted on your head. So they needed a system that would be able to generate stuff that would change dynamically in response to, you know, what people were seeing and whatnot. But also be computationally not so expensive. So the advantage here is that it also didn't take up a lot of memory either. So the nice thing about synthesis is that every time, you know, you trigger a note, you can make it slightly different. Whereas with samples, it's kind of like you get sort of the same thing every time. Okay? So like the layers that I'm showing here, these are all actually dynamically generated from the other pieces of music that are playing. So what I did is I basically made like little, down here anyways, these are like little arpeggios that are generated from the other notes. And so every time I play this piece of music, it's actually different. So yeah, for me, I can literally listen to this piece. I don't know, I just sort of find it calming. Yeah. I think that's where I want to get with my music, is that I can actually listen to it. You had a question, yes? What I'll do is I'll do them at the end. The main reason being is that if I screw up one of the demos, then I'll want to have a little bit of time to try and get back on it. But please, yeah, I will do questions at the end, and then we can use the mic and stuff like that.
Yeah, I forgot another just a quick question. How do you implement the timeline here? Because it changes over time. What's that?
Oh, yeah, sure. So, as far as the timeline?
Yeah.
Yeah, okay, sure. So, fair enough. So what it does is it actually, it counts quarter notes, and then inside this little thingy here, this is where the mix groups are, and this is where the current place that it is, sort of in all of these mix scenes. So this is like the first channel, second channel, third, blah, 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 blah. So the percussion, I guess, is 1 over, say. And then the first number is how many milliseconds it takes to fade to that. And if I wanted to, I could just simply jump to that section as well and make it nonlinear. But the way that it is currently, it takes in the song position, and then it just divides it, and it just loops through there and picks a scene depending on, you know, where it is. Yeah. So, but if you do have questions, I don't know, maybe write them down so that we can get to them all at the end, because I'm going to try and rifle through some more demos and stuff. So hopefully that gives you an idea of, on the music side, that's the kind of stuff that I like to make using PD, and I hope that it slightly convinces you that it's worthwhile as composers. Because I think that there's a lot of possibilities with it. So yes, whatever, it's like nerdy and like maybe it's complicated, but it also just gives you a lot of power to do what I think is really exciting, like new things. So let's cut that one out. All right. And so yeah, that's sort of an example of complex stuff, whereas over here, this is, you know, very basic. And I guess we could quickly do a demo there. Oh, so yeah, I know. I was working on this presentation until today-ish, and I'm learning Spanish, and so it's this guy, the Duolingo. He gets me. So I was thinking, like, how is this related to my talk? And I thought, well, visual coding, you could also just call it like a visual language. And with that, I really do wish there was like a Duolingo for visual coding, because Spanish is hard-ish. I don't know. How many people know more than one language here? Yeah, pretty much. That makes sense. So to me, like I've talked to other people, learning visual coding is like learning another language. Sure, it's hard, but then it like literally opens doors for you. It gives a lot of more possibilities to have more creative control over your artwork and what you want to do when working with games and game audio. So it'd be great if there was Duolingo for visual coding, because they have an amazing system to like teach other languages. I'm not sure how they do it. Maybe, throw around some ideas, but that really is the thing, is that if you're, it's just hard. And so it would be nice to have more help. And that is one of the things that we try to do at the school, is to try and help people just sort of do, just try it out, see what happens, and you can give me your design ideas, sort of interactive ideas, and then I'll sort of, it's like I've said, digital finger painting is like just have fun with code, have fun with just throwing stuff together, and then having somebody that can help out, like guide you a little bit, can sort of take it to the next level, so you can go like, oh, I'm stuck at this point and I just need to get over that. So yeah, it would be nice if we had Duo's help to help us out there. So enough about Duo, here we are. But you even look at the aesthetic of this. I know that it's hard to read, but this is UE5, like Unreal Engine 5, and it's kind of like, I don't know, sort of the vibe on there, even though it's like dark mode, is like, it's literally, I know you can't read it from there, but it's hard to read anyways. So we have meta sounds, which are digital signal processing graph. So that means that it actually doesn't do scripting. It gives an overlay of how the signal flow works between different things. So it's exactly, if anybody uses modular synthesizers, it's that same thing. Without sort of logic modules, it's just basically like it's more like when playing guitar, plugging guitar pedals into each other. It's like that. The guitar pedals are not really smart. They're not like, oh, hey, this person's playing really hard, and so I'm going to route it like less to the distortion or whatever. It's sort of the not smart part of it. Whereas the blueprints, that's where the behaviors and the visual scripting comes in. Okay. Here's some more things. Like this is just to do with PD. I won't show that. We already sort of saw that with the Pluto side of things. And so within Unity, you can do visual scripting as well. So if I zoom in a little bit to make it a little bit more legible, so that it's easier to read. Here we've got some debug stuff, so we can send a message out there. And then eventually, what we do, this is just sort of like, when a collision happens, then it does different things, and it just takes it's splitting the string, so it's finding out which object it actually hit, and then it outputs that to the screen. So this is possible now. Has anybody used visual scripting in Unity? Yeah, couple? Yeah, I barely used it because it's very new. It's within the last year, and the audio stuff in Unity is admittedly not that great. So they're just sort of getting started. Hopefully, there will be more new great stuff happening soon. There's Max for Live. Have people used Max for Live? I haven't used Max for Live that much. Yeah, cool. So the great thing about that is that they've figured out a nice way to give revenue to the people that make modules. So that means that you get more better, gooder modules being made. There's nice graphics, easy implementation. Sometimes if they make it open, that means that you can actually update things, which is kind of cool. And there's a huge library of possibilities there. All right. This is me working on the organelle. There's hardware that you can run pure data on. This was sort of a bit of a side note. And okay, so this is more of a key concept. So this is what I was sort of talking about before, is that sort of this is, I guess, the opposite way around. But at the base level, you've got the sound driver, then you've got like the nodes of the optimized code that you're using. So that's like, this is more the interface stuff at the high end, but this would be like the nodes within Unreal Engine 5, right? And then the low-level implementation, this is sort of the more complex stuff, like working with, like that Pluto patch, kind of complex, right? So at Electronic Arts and other companies, sometimes a person that's more of a technical sound artist will do this, whereas if you're just getting started out, you might be on this side. So it's kind of like more like introductory Spanish, right? Donde está el baño, right? Whereas when you actually learn how to speak properly, then you get to this and you can do more stuff. But it's okay to get started here because, we all need to start somewhere, right? And then on the high end, then you have a nice graphical interface in which to, interface with things. All right, here's some systems that you might want to try out. Bespoke, Biddual. They're not visual scripting so much, but they do. I wanted to show them because they're kind of like more pretty. Bespoke is really interesting. When it's animated, it shows like audio going through there and stuff. So I think that's an important thing for when you're getting started out, is that it's just nice to look at things that are nice. Not so much pure data. It's not that pretty. Shaders. I mean, this is once again sort of a side note, that visual artists use this kind of visual. Instead of a DSP graph, this is kind of like a way of encoding a shader. So it's a way of changing the graphics. And this is important as far as working with visual scripting. Yeah, it'd be nice to be able to save and organize patches, curate user patches into official patches. It would be great if we had something like GitHub for visual scripting, so that you throw it all in there and you can share with people easily. They're doing this with, there's a repository with Unreal Engine 5 that doesn't have a lot of stuff in it yet, but hopefully it'll get there. If you've used Reactor, the user library is awesome, super fun. And then the thing that's neat there is that those patches and those environments will like bubble up to the factory ones, and then those people can get paid out as well. So. And then there's, this is not visual scripting, but Sugi Studio Games has the game synth. And then, for PD, there's sort of patch storage where there's a lot of patches that are available that you can use. You can compile visual scripts. So this is more on the tech side. So one of the things with programming is that, if you're interpreting the script at runtime, it naturally makes it slower. But what you can do is that you can compile it, and this is what Unreal Engine 5 does with blueprints, I believe, I think, now, to make them more, because when you literally actually click like compile, and that'll make it go faster, but it's not necessarily as fast as C++. It just means that it crunches it down, so it requires less processing power. And with pure data, you can use the heavy compiler. There's an example of heavy, and you can use, so you can compile PD into C, and then you can integrate it into Wise and whatnot. But the problem is that heavy, they stopped development on it, and the tool chain is not that great. So I guess you'll have to talk to me about details on how to use that. This is another solution, is that they actually use PD in real time, so it's interpreted. So unfortunately, it's slow. And that can be used in Unity, and it supports spatialization. So as far as the advantages, so non-coders can use visual scripting. This seems kind of doable, right? And it's real time, so you can try things out, like break things, see if they work or not, and hide complexity if you need to. Hopefully it extrapolates well to the future. So blueprints that work now, hopefully they'll make them work in the future by, same thing as like when you open Wise, you open an old session and it'll actually like upgrade it to the current version, right? And instead of having to type everything in, like say, Python or something, the syntax errors, like the things that you need to do with text are reduced, so that's nice. And then there's a lot of open source possibilities, either through the repositories or otherwise. So the challenges are, it's complex. So this is a Reactor patch. So yes, you're still programming. We've seen examples of visual spaghetti. The RSI, so like hurting your hand because you're like, It's honestly like there's a reason why they call it like patching, because it's like, I mean, I know that it's from patch cables, but for me, it's very similar to like, you know, like needle and thread, like putting a patch on clothes. And the thing is that, you know, dragging all these stupid lines around to make it so that it hits that little dot is annoying, right? So say Bespoke and other systems, what you can do is that you can take this one, and then you just hold it and drag it over that, and it'll actually be a little smart about it and connect the things that you want to usually have connected. So this is what's happening for the future. So the challenge now can be overcome. Yeah, it's slow and less compiled. It's, you know, difficult to diff patches and merge changes. Like I said, no GitHub. And yeah, it's still coding, so. I guess, how much time should I use? Because I have a few more demos. Okay, all right. I'll keep going? Okay, all right, cool. So I should show you, I showed you Unity, so I'll show you Unreal Engine. I hope. Once again, launch. All right. And then we'll do a couple questions and stuff. Unless this thing, we could also do questions while it's compiling shaders as well. Okay, so this one, of course it doesn't know. Browse. Oslo, that's where we're at. Okay, so the example that I want to show you, it uses synthesis and physics to create the sound for a bouncing ball. It uses what's called the Karplus-Strong algorithm. Oh my gosh, they're still compiling shaders. This is great. Okay, so I'm just going to play it. And, okay, this is great. So hopefully it makes audio. Hey, okay, cool. Is that in stereo there too? Or is it kind of mono-y? Or I'll play it again. So you should be able to hear it in stereo. So you hear it like bent up at the end, right? So every time this ball lands, because it's driven by physics, it's going to be different every time. And yes, it's not naturalistic, but not all games need to be naturalistic, right? Yeah, all right? So, cool. How did we do this? Well, let's just have a look at the meta sound here for that. Here's the ball. And, yeah, I mean, honestly, this is quite small, given the amount of stuff that needed to have happen in here. And how do I zoom in? It's like, oh my gosh, okay, good. Good. So a lot of this is just control type stuff. So, okay, great. So yeah, higher velocity, higher pitch, and louder. So apparently it's producing a high velocity when it's, you know, rolling around like that. But all this is just noise. I don't know. Yeah, and then it goes, it's enveloped, okay? And then it goes through here, it goes through a delay line. But then the tricky part is that it does feedback. And so similar to like when I was hitting that metal thing, where there was feedback there, I use feedback here that's really small to generate like that sound. Like it's supposed to generate the sound of like a plucked string, but it also creates this sort of metallic bouncy sound. So yeah, that's basically how that works. I can go back to the presentation, and I was going to show some more stuff. So the near future, we could add PD, like plug data, to our current middleware. Maybe we could do visual scripting in VR. We could combine text, like Python or Lua with it. And we can also make it more natural, because the computer, this stuff, we don't necessarily think this way. It would be nicer if the computer sort of met us halfway. And like the language of visual scripting was more natural. And then further, way in the future, we could do stuff like this, where you do like a visual script, and then it looks at the library, and then it figures out, similar to like this DALL-E thing, it's able to scan a whole bunch of like existing images / scripts, and figures out how to add stuff like computer-assisted coding, basically. That would be nice, right? As far as possibilities for the future. And I know that we'll hear more about AI later today, too, as far as it relates to audio. Okay, cool. So, questions? All right. Questions are good. So you have to come up to the mic, though, please. Okay.
Hello.
Hey.
Thank you for the talk.
Sure.
It's really interesting. So my challenges with visual scripting and blueprints and meta sounds is that it's hard to get a visual output of the audio, that there's no timeline, there's no wave editor, and especially when you're dealing with interactive or adaptive music, then it's really hard to have like this visual overview that you have in Fmod or in Elias or so on. Is there any tricks that you know so you can get more visual?
Yeah, I guess I would say that your question is something that they should fix. Because I think that that's one of the things that Fmod was good at, is that they sort of made like Ableton-ish, like with when they did, because they originally had Fmod Designer and then they made Fmod Studio, and with Fmod Studio it's a little bit ish like Ableton, so like at least the look of it, and they have a timeline on there which makes more sense, and so I think that it would be nice if, UE5 was a little bit nicer that way, where, say, like I showed that example of Bespoke, where, I mean, you didn't see the animated cables, but it would be nice to visually be able to see the audio, like the waveform come out of the cables, right?
I actually think that that's coming in Unreal 5.2, if I'm not mistaken.
Yeah.
The exact thing that you're talking about there. So that's definitely a big improvement.
Yeah, so I think that, having better, user interface or user experience stuff will definitely help. I think part of the reason why they don't necessarily have like a default timeline is because they're trying to make it more flexible from the beginning. But it would be nice to sort of have like a little stepping stone for people that are used to using like sort of the idea of linear time, so that they could have more access to it, like you're saying. So, as far as tricks, well, you could. There's actually there's a project that I can send you that, because what they did when they were showing their convolution reverb is that they have some visualizers for that, and they look quite nice. And there's actually a visualizer plugin where you can at least see the, like the spectrums moving up and down. And then there's a whole library of stuff by, what's his name? Arthur Barther or something like that. He's got this funny name. And there's all these great little projects that he's put together in UE4, and I think that they basically work in UE5 as well. So yeah, I think that basically being able to see things visually would help. Yeah. Yeah.
Cool, thank you.
Cool, thanks. Yeah.
Hello. Yeah, we have a question from chat as well.
Hey, chat. Hello. Great name.
Yeah. Hova from chat is asking, how easy is it to set up Pure Data to do synchronized loops like a sequencer, and being able to say play drum loop at the next 8th step or 16th or 32th, for instance?
Yeah, it's not too difficult. I'm not going to attempt to do it right now. Exactly. But yeah, the way to start that out. Okay, sure, why not? I'll be. Yeah, exactly. Let's see if I can do this. Okay, PD, come on. I guess I'll have to. Oops. Oh my goodness. Okay, and then I go down here and I go into PD, and there is, if we look into this, if you go into the Metro object, and this is another nice thing about PD, is if you right-click on it, you can get help, like contextual help. But then what you can do is that you can actually also like just grab the code out of there. So if you're like, oh hey, I like this, grab that, and then you just like stick it and go, oh, thank you very much. There it is. Like now I have that, and I can use that in my own patch, right? So this is something that PD does quite, sorry, I'm having a hard time with the scroll and the trackpad, but there we go. And so with this, the Metro object, that 120 is BPM, right? So what you could do is you could basically use that as a trigger. That's what this thing is here. And then you would just trigger a sample to trigger at a BPM like a steady rate. Okay? So, yeah, it's not that hard. Other questions? There must be other questions. How about for people that I'm curious about people that are on the edge of learning, say, visual scripting or implementation for games. Can I see hands? No, nobody wants to learn it? A little bit? Okay, a few. Maybe. No, I know. I'm not trying to like bully you into it. I mean, I did do a talk about it, so I mean, like, do you want to see sad boo? But yeah, I guess that's the main thing, is that I'm hoping that this talk will at least get you over the hump of like, okay, maybe, whatever, I'll try it again kind of business. So, yeah. And if you want to contact me, ask me more questions, you can contact me at the school. That's the top part. The bottom part is me personally. All right, so I guess what we'll do is, if you have questions for me, I'm here for the next week or so. So just ask me questions in person, or if you don't want to talk to me face to face, you can be sneaky and do it online as well. All right? Okay, so thanks a bunch.
Thank you so much. Thank you so much, Leonard, thanks for showing us the future of implementation. Now we have a short break, 10 minutes break. So yeah, thank you.
game audio studies like as formally. In the years before, you could only study it through YouTube or online programs, and right now there are still online programs in Latin America, but they have more like formally established in university programs. Studios. So we also run a survey for the studios in Latin America. The studio size, 65% of studios are under 10 people. So they are pretty small. But 60% have one full-time audio person. So that's telling us that they value audio as an important part of the studio. So that's pretty good for us. The age of the studio, 50% of the studios have over 3 years. So less of them have existed for less than 3 years, 50% more than 3 years. So pretty new. All the studios are pretty new. But like I said, they value audio a lot, so that's great. Oh, that's what we can take away from this. Okay, the future. In the future, we can expect a big influx of indie games that are coming from Latin America with music, sound design, and voice acting by Latin American professionals. And these are some games that are coming out in the next year, more or less. And a lot of them, I think all of them have like original audio and sound. I'm gonna show. Oh no, I lost the place. Give me 1 second, let me find it. Oh, here it is. And this is a game I worked on that's coming out next year. This is not for self-promotion or anything, but I wanted to show you one of the games that's coming out next year.
El videojuego Lonesome Village se trata de un coyote que se llama Wes, que se encuentra en esta villa a la que ha acechado algo maligno. Entonces la misión de Wes es ir a esta torre malvada que de un momento apareció y resolver todos los acertijos para liberar a la villa.
Y fuera de la torre va a tener que interactuar con ellos para poder ayudarlos a recuperar sus vidas y a recuperar el pueblo Lonesome.
Tú eres quien va a esta gran aventura de jugar el videojuego. Entonces lo que hicimos fue tener pues melodías, grandes melodías en los violines que fueran muy emotivas y tener también acción, que fuera como que las texturas fueran un poquito más de acción, un poquito más movidas. Lo que yo intenté hacer a través de la música de Lonesome Village fue mezclar este elemento de aventura con este elemento un poco más suave y amigable de estar socializando con los otros animales.
Algo que queremos que la gente sienta con la música dentro del juego es que asocie todos estos momentos que va a tener para descubrir la historia con una melodía.
Yo espero que la gente se sienta inmersa en el videojuego, que cuando se va a las diferentes áreas se sienta de verdad que están ahí, cuando estén resolviendo los acertijos sientan pues la presión de hacerlo, que cuando lo resuelvan se sientan aliviados, se sientan felices. En general que lo disfruten mucho y que lo disfruten con sus familias y con sus amigos y con todos.
Sorry. Okay, so as you can see, Game Out in Latin America is growing, and it's growing at an exceptional pace. Let me see my notes very quickly. Okay, yeah. So as you can see, some indie studios are using orchestras, even though they are indie. So I think that in the future, we're going to see more games that have original audio, original sound, that have live music, and who knows, maybe we'll even see like the first AAA game coming from Latin America, because right now we only have indie studios, indie games. But the cool thing is that it's not only growing locally, it's reaching out and collaborating internationally. These are some games that have audio made in Latin America. Far Cry is set in a fictional Latin America city. So in the next video, you're going to see that they reached out to Latin American composers and sound designers to bring life to this fictional place. Well, Ashini the Pit does sound design and music for games, and they have people from working in Latin America making sound for those games, same as Splash Games. Homestead Arcana has implementation, sound design, and music made in Latin America. Killer Clowns the same, Witchfire, and Tetris Beat, the whole audio team is based in Mexico. And I also lost my place here. I think it was around here.
Far Cry 6 is set in the imaginary country of Yara. Yara is a Latino-Caribbean island ruled by a tyrant called Anton Castillo. Bringing Yara to life through music and sound was not an easy task, and I knew I needed a diversity of voices, of experiences from all across Latin America to make it. So we picked a selected group of composers and artists to bring their voices, their experiences, and their point of view into the game. Yara is divided in regions with different approaches, but a common sense of revolution. In the central region, our hero is Talia. She's the singer of Máximas Matanzas, a rap band that provoke and challenge the regime with the lyrics and the rapid-fire rap. We needed someone who was the real thing, so we called Gabilonia. Gabilonia is a rapper from Venezuela. She started in the dangerous streets of Caracas, and she went from Venezuela to the main stages in Latin America and North America.
Yo no sé por qué le pusieron ese nombre y no le pusieron Gabilonia. No entiendo. No entiendo, de verdad. Me identifico muchísimo, es que no te puedo decir más nada porque es como que yo me metí en el papel con Talia, de verdad.
Falla, porque en la calle se dice que viene batalla. No tenemos miedo, mi gente no falla. Tú sabes que seguimos dando la talla. Hey, canalla, somos los llaranos, tú sabes que no se desmaya. Pasa la raya, y bueno, es un pueblo que arde metiendo la galla. Yo me extraño.
Sí, yo creo que Talia puede cambiar a Yara. Con sus palabras, con su voz, con su rapeo, con lo que diga. Porque está hablando con la verdad. Y cuando uno está hablando con la verdad, no hay nada que pueda con eso.
¡Fuck Castillo! ¡Fuck Marquesa! ¡Fuck Paraíso! ¡Rejoder a la muerte! We don't stop, you hear me?
And if you want to see this video is up on YouTube. It talks about all the artists that collaborated in the audio for Far Cry. But I'm gonna keep going. Okay. Some members of our community are also in leadership positions in some of the largest studios in the world, Ubisoft and Bungie among them, and they are in audio positions along the world. So they are trying also to help us to provide. We recently had Eduardo Weissman, which is the audio director for Far Cry, have a Q&A with us. And yeah, so they're really trying to help our community and help people from Latin America, which we think it's awesome. Oh yeah, and so Netflix is just coming out with their first games, and this is the game for Money Heist, and the audio, it's actually the full audio team is in Colombia. Just a small teaser. We also have international studios that have headquarters in Latam. We have Keyword Studios and Amber, and they mostly do audio. Well, they do QA, audio QA, but they also do original audio. And to talk to us about that is a video here. He's another one of the co-founders for Game Audio Latam, and he did the music. He did the implementation for Tetris Beat in the studio Amber. So he's going to talk to us a little bit about that.
Hello, Game Audio Norway. I hope you're having an amazing conference. My name is Rodrigo, and I'm also one of the co-founders of the Game Audio Latam community. Today, as part of the talk my friends Majo and Jasmine are giving to you, I will be showing you a quick glimpse of the Tetris Beat WISE project, which is my most recent work. Okay, so as you can see, here we have one of the music tracks of the game. This one is called Korobeiniki. It is the official Tetris theme remix of this game. In this WISE container, we have multiple stems that help the game have a better synchronization with the visual part. I'll explain how in this video. This all happens thanks to the WISE Mirror plugin, which is responsible of receiving signals from the current track playing and send them to Unity through WISE RTPCs. So as you can see, we are sending the track C and the track remix to these auxiliary buses called mirror high, mirror low, and this one to mirror mid. Now we're going to go to the VFX bus and see the auxiliary buses that I'm talking about. So mirror mid is just the WISE Mirror plugin sending through an RTPC the signal information that is going to receive Unity, so it can do different things with the visuals depending on the frequencies that are currently playing of the song. So for example, in mirror mid, we are only receiving this bandpass of frequencies. Then on mirror high, we have only a high pass of 1000 Hertz, sending the information through the mirror high RTPC, and also the mirror low, that is a low pass of 100 Hertz, sending the information through the WISE mirror that is attached to the mirror low RTPC. So having this said, we are now going to see how this exactly works in-game. So you can see the houses in the background and all the other buildings moving thanks to the information that currently WISE is sending in Unity. But what happens? We bypass the auxiliary buses and exactly WISE Mirror plugin. So I'm going to bypass the 3 of them, and let's see how it works. So as you can see, there is no more animation in the game because all those movements are being triggered by the WISE Mirror plugin. So I'm going to activate the mirror one by one so you can see how it works in the game. Let's start with mirror low. So only the middle buildings are moving to the rhythm of the current playing music. Let's go to mirror mid. You see the disco ball in the middle moving to the rhythm thanks to the mirror low, but I think right now there is no mirror mid information being required. So let's try with mirror high. Just activate the bypass, the meter. Let's play a little bit what happens, how it reacts. So let's try these ones again. Let me bypass all the meters and quickly activate them while in the game. Let's get to the part where the buildings are moving. So no movement at all. Let's just activate them. I don't know why the game pauses, but now you see the importance of this meter. And the little reactive system that we created for a rhythm game like this. So I think it really helps to have a more styled game break and give it more life. Yeah, thank you very much and hope you're having an amazing conference. Bye-bye. Hello, Game Audio Norway. I hope you're...
Okay, so why is Latin America growing at a fast rate? Lower living costs result in studios having to sell less game copies to be sustainable and decide to work on a following title. Multiple governmental benefits favor software development companies via lower taxes, grant, and other financial aids. An increasing amount of game development courses in public universities increase the interest, affirms the possibility, and promotes networking among new professionals. There are new communities that are making it easier to get into the industry and connect with professionals. Some of those are the Game Devs MX, which is the Game Devs from Mexico, Women in GameX, Women in Games. There's a new one that is Argentinian video game audio designers. So, yeah, a lot of new communities. And hopefully us, you know. And what we can take away from this, Game Audio in Latin America is open to collaboration and eager to participate in the international market. There is an increasing amount of highly trained professionals, and we at Game Audio Latam are trying to help and educate new audio designers into the video game industry and are trying to create connections and more resources and opportunities. So here's our call to action. Spread the word about Latin American game development and game audio history in the region. Collaborate with Latin American game audio designers. Play and support Latin American games. Ask your Latin American game audio friends to join our community. Keep fomenting friendship and collaboration between game audio organizations and communities. And generate a link between game audio communities to generate resources in English, Spanish, and many others. And I took a note from Erin's presentation yesterday, and I made this QR code to a list that we have of 155 games made from Latin America. So if you want to just check them out, I'm going to leave this up. And that's the end of my presentation. So, yeah. Thank you.
Thank you so much, Maria Jose. We have time for 1 or 2 questions. Any questions? Yeah.
Oh, you have to go to the mic.
Hi. I was wondering about the location of the companies. Is this like a big city phenomenon most of all, or the like centralized in the capitals? Or,
yeah, it mostly is. Most of the studios are in Mexico, are in the big cities like Mexico City, Puebla, which is where I'm from, Guadalajara, Monterrey, which are the big cities in Mexico. And it's the same thing in Argentina. Like the big studios are based in the big cities. And even there's a sense of country. If the country is big, of course, there are more studios, there are more people. I know, for example, in Ecuador, there aren't many because it's also like a very small country. But Mexico and Argentina, like I said, are pretty big. So yeah, it's mostly a big city thing.
Are there any more questions?
No?
No.
Okay.
Thank you so much. It was very
Thank you.
interesting to see. Yeah.
Oh, yeah.
Let's let's have a new break then, and we'll be back at 12:15. Okay. Okay. Before we continue, I have a message. We have been experiencing some difficulties with the live stream, but it's been recorded on the side, so it will be published in its entirety. But yeah, we're back, and picking up the thread of cutting-edge technology, our next speaker is Oliver Getz. Oliver is a technical audio producer and composer and Chief Executive Officer at Nordic Scoring. Today, he'll pull us into the universe of a generative machine learning technique called variational auto-encoding. This is a solid next step into streamlining audio production and can potentially shorten audio production time by generating variations of a sound created by a sound designer, which could mean less time on tedious tasks and more time for being creative. Oliver will also dive into some important questions about artificial intelligence, like what is it that makes us think a machine is intelligent and what can we use it for? And why is it important that we talk about it here before everyone else talks about it? What should the industry keep in mind? So let's give it up for Oliver Getz.
Okay, you can hear me? Yeah, good. Oops. Yeah. Yeah, AI. Oh boy, what have I got myself into? And also, what's happening with the text? Okay, never mind. Yeah. I'm noticing the lack of stickers, by the way, on all your computers. You should be really ashamed of yourselves. No, I'm kidding. Yeah, we've seen some very impressive developments in AI, like the past years, and even a lot in the past 12 months. As AI becomes more integrated into our daily lives and eventually our work, I think it's important to keep an open discussion about like what AI is, what it can do, and so forth, like Sarah explained. Yeah, but first I want you to tell me what you think AI is. So can you get up your phones and go to menti.com and enter this code? We'll just take a couple of minutes. Let me know if it's not working, by the way. Don't just sit there and pretend like everything is fine. I'll assume it works. I mean, that would be the most Norwegian thing to do, so. Okay, I see heads are coming up, so starting to get some answers in there. So look at this. Woo! Okay. That's pretty cool. That's pretty cool. Smart, intelligence. Okay, a lot of stuff is still coming in. Tool, yeah. Scary. A lot of people did scary. Scary, artificial intelligence, and intelligence. Those are the three most answered ones. Machine learning, yeah. This one also, just with a spelling mistake. This is a very Norwegian version. I like that. Augmented intelligence, I really like that. Like a step above intelligence. Self-learning. These are all really good. Huh? Oh, where? Oh. Yo. Okay. Cool. How can I make this? I'm just going to do that. Cool. Yeah. So those are all really good answers, and we're going to talk more about that today, like what AI is, try to establish some common understanding of AI, what it can do, what it cannot do, and what kind of challenges that we're facing in the coming years and presently, and also stuff we should have talked about like 10 years ago. So yeah, there are two main categories of AI. The first one we call strong AI. And strong AI, I'll just leave this up here. Strong AI is an AI that we try to model after human intelligence. So it's basically we're trying to make another digital human in some way, shape, or form. And what this entails is that it should be able to respond to you in a very natural way, but it should also be able to handle a lot of problems that you throw at it, or at least give it a very decent try. And right now, today, this is purely a theoretical concept. This is not something that exists. It's basically a thought experiment. But people are doing research in order to try to get this to happen. On the other hand, we have weak AI. And you may think that's kind of lame in comparison, but it really isn't. Weak AI is more of a specialized piece of software that does one task really, really well. And that kind of task could potentially be image recognition, right? Like in knowing what kind of objects are in an image, or what kind of sound is being played in an audio file. It's also really good at categorizing things, finding things that are similar, patterns, and like mushing them together. Finding common threads, basically. Yeah. So all of you may be familiar with like the most common video game AI, like an NPC that responds to the input from a player. For instance, does the NPC run away from the player? Do they run towards the player? Which path are they taking to get to the player? And this is all based on like complicated math stuff that I have no idea how it works. And also, when they get to the player, what do? Do they talk to the player? Do they attack the player? Do they give the player an item? Or do they give the player a hug? You don't know. This kind of AI is something we call rule-based AI. So basically, a developer is creating an if-else kind of relationship. Like if something happens, then we're going to do this one thing. If this other thing happens, then we're going to do this other thing. So, for instance, in the case of The Sims, that could be you have your character, and you're instructing that character to talk to another character, and that's kind of the input. The rules for that would be how does this other character respond based on whether or not their needs are met or if they like your character at all. So yeah, this kind of AI has been around for a while. We're all kind of familiar with this, I hope, if you've played video games ever. So what's the fuzz with like modern AI? And I call it modern AI, but it's really been around since like the 50s, but we just didn't have the computational power to like make it work. Yeah, so what's the deal with this kind of AI? Let's talk about math for a little bit. Do you like math? Oh, this is very conflicted. I don't like math either, but it turns out that math can be very, very useful in certain scenarios. So the way we're used to working with math is that we're given an equation through like school or someone who is a bit more knowledgeable than us, and they teach us how to use this equation in order to solve a specific problem. For instance, like x divided by y is a very simple equation that tells us how big of a portion is this number of that number. It's like, yeah, 10 divided by 2, or whatever. And this, yeah, try to imagine that you had the answer to that, but you didn't have the equation. You have a ton of numbers, but you don't really know what produced those numbers. And there is a branch of AI called machine learning, which is the process of finding this equation. So like given your data set, your numbers, machine learning is the process of finding out what the equation is that produced those numbers. And in machine learning terms, this equation is called a model, which you might start to hear being thrown around. So, yeah. There are different types of machine learning, without going into detail about like all the different kinds. But one thing that's common for all types of machine learning is probability. Yeah, that's all machine learning is. It's calculating the probability of an outcome. So that can be, given all the data that we've captured about you for the past 15 years, are you more likely to press this ad or that ad, right? Because clicking those ads generate revenue. So we want you to click the one, or we want to present you with the one that you're most likely to click. It can also be, what's the most likely pixel, the next pixel color in this row, based on all the images that we have in our data set, which can be like billions and billions of pixels. But it can also be, what's the most likely note at the end of this phrase in a musical sense. So, oh yeah, I should probably, okay, it's too late now. This is a brain. I was gonna say, like, if you don't like brains, like, look away, but yeah, I kind of fucked that up, didn't I? Okay. So, machine learning is then not the solution to every problem. At least machine learning AI is not. It is the solution to a very specific kind of problem. And the kind of problem that it's really good at solving is problems where the rules kind of change in unpredictable ways, or where we cannot quite explain our experience to a computer or even to each other, or when we lack the expertise necessary in order to solve a problem at all. For instance, a good example, musical example, is if you have an audio file of a stringed instrument, how do you tell the computer that this is the sound of a guitar and not a lute or a bouzouki? Right? It's a very complicated problem. Without like telling the computer this is a guitar, it's just not gonna know. Without actually putting it in the label or whatever. Another cool example is this is basically image recognition. This is my friend Joachim. He is, in this picture at least, showing me how his app is working, where he's been training a model to recognize the joints in his hand. And based on like where his index finger is on the screen, captured by a webcam, you can like change audio stuff. So basically making audio change by like pointing places. But you can assign an ID basically to all of these things and do different calculations, different musical things with each joint. So you can essentially like make music by moving your fingers. It's pretty cool. But like, how would you explain that to a computer, what a hand is and how it's moving and all that stuff? Great opportunity for machine learning. You're already kind of using machine learning in one shape or form. If you watch Netflix or listen to Spotify, you're presented with content that you're most likely to make you most likely to stay and not cancel your subscription. In the case of TikTok, it presents you with stuff that makes you more likely to keep scrolling, and that's why it's super, super addictive, because at least when you get into it, it's gonna show you the stuff that you really, really like to see to get like your dopamine hits, and then you're just stuck scrolling for days. And most of you have probably heard of isotope products like Ozone or RX. Use it probably regularly in your work, and they are also based on this technique called machine learning. Are you worried yet? No, just kidding. I was a bit worried, like if you, like how you would think about this talk, being like someone who, is this gonna take my job or? This is the interface for Ozone. One thing you should be aware of is that a lot of products are going to start hiding their AI. A lot of them are not going to tell you that AI is being used at all. Isotope is really nice because like they have a blog and they talk about this stuff. But a lot of products that are going to come out and are coming out are not going to mention AI at all. In the case of, if you're not reading the blog, the Isotope blog, then you might not know that the assistant is an AI. I want to talk about some experiments that I've done. So the title of this talk comes from a set of experiments that I did this past spring. And I used this technique called a variational autoencoder. And the specific trait of the variational autoencoder is that it generates variation within a specific sound. So, and in terms of data, variation means noise. So when I generate audio with this, I would expect to hear some sort of noise introduced. And I wanted to know if I used, in my data set, if I used very noisy by default sounds like, let's say, gravel footsteps or grass footsteps, if that would kind of negate that effect and render it a bit more useful. So a variational autoencoder consists of three parts. The first is an encoder part. And the encoder takes an input, runs it through a function, and a function, if you've never programmed before, is basically, it takes an input, does some calculation, and gives you an output. It's not really the important part here for like the general overview. But yeah, these green dots are functions. In machine learning terms, we call them neurons, and this is an artificial neural network. The input is audio files. So essentially what it's doing, it's compressing the audio. It's taking multiple of these parts of the audio file, pushing it through this function, which then generates one single number. This information is then stored in what we call a latent vector. A vector is just a set of numbers, but it's called latent, which means kind of hidden. We can't see it. And it's not that we can't see it. It's just if we open it and look at what it is, it's gibberish. But it's kind of, because it's compressed by a computer, it's kind of like opening a binary file and trying to read it. It's just, we can't understand it, but hopefully the computer can. The third part is a decoder, which is exactly the opposite of an encoder. And yeah, it just decompresses the sound, and voila, you have an output, which is identical to the input. Amazing. So now you've compressed audio, and you decompressed audio, and you're left with a slightly noisier version of that input. So obviously, that's not the remarkable part. The remarkable part is that we can sample from this latent space randomly and get variations of the output, audio files that we've never heard before. And basically what that is interpolations between different sound effects. In my case, sound effects, but you can use whatever source material you want. So how many of you have done like programming stuff? Yeah, quite a lot of you. Okay, so interpolation usually means like we're finding like a number that's between two other numbers, right? But in this case, you can do it between entire audio files, which can be like thousands and thousands of numbers. And if that's not cool, I don't know what is. Okay, so I was thinking we should listen to some of the generated sound effects that I made. Do you want to hear them? Yeah? I'm not convinced. Do you want to hear them? Yeah. Okay, amazing. Okay, take a listen to this. Wow. You hear that? Are you disappointed? Because I was disappointed when I heard this for the first time. Yeah, so this was the very first time I ran my model. And it's, yeah, I was like, what is this? Okay, what if I just tweak some settings and train it for a little bit longer? Let's see what happens then. Wow. It's like slightly louder and slightly brighter noise. So basically what I created was a latent space that I could sample and get different noises, just files of random noise. So that's not super remarkable. Let's move on. Okay, so that is kind of interesting. What's interesting about this is that it's starting to get the contour of a footstep, right? It's the energy is starting to amass in like the beginning of the audio file and like gradually die out. I think this is like experiment number like, I don't know, 15 or something. And then we have some, yeah. It's starting to become more and more like a sound, like a footstep sound. And then, okay, I don't know what the hell that was. Yeah. I have looked through my data set so many times trying to figure out like where does that high-pitched thing just like get entered? Like what the hell is that? Yeah, and yeah, that's kind of how far I got with this. And I do hesitate to call these failed experiments because I didn't learn a lot about machine learning and AI and generated sound effects. But it was obviously nothing I could use like in a real production. I think this this failure comes, like my educated guess is it's because, well, about 70% because I have a very, very small data set. My data set is about 500 footstep sounds of grass footsteps, and it's trained 500 times. So it's gone through all of those files 500 times to learn sort of how they sound, but not really. And really what you want is at least 10 times that in order to give you an idea of like how much data you need in order to generate something. So yeah, 70% like just a terrible data set, and 30% just I don't know what I'm doing. But it is interesting that it kind of starts to get like a similar contour, so you can like tell it's sort of working, but yeah, I didn't have time to like go out and record 10,000 more sound effects. But the good thing is I discovered some people who have done this much better than I have, and I'm going to show that to you. You can see here that the audio file is completely new every time.
So yeah, pretty fun, and it's actually nice to see that actually GANs can work in a wide variety of acoustic sources.
So what he's essentially doing, this thing is essentially the latent space. And wherever he puts this thing, he's sampling from the latent space and generating a new sound effect if we didn't get all these ads. Yeah, generating a new sound effect every time. And how much you can generate kind of depends on the size of your initial data set and a lot of more other parameters. But I think that's kind of interesting, and I think this is kind of in the direction we're going with this. This was done 2 years ago, so you can imagine we've gotten even further today. Another cool machine learning example, that I want to show you. Oh shoot, do I have to go through my entire thing again? Yeah, I do. Can you just imagine me talking like super quickly right now? There's this weird thing in where if you have like a YouTube thing going, you can't press enter to go to the next slide, so I have to go out. Okay, I just wanted to go in so I could click this link. Okay, this is very interesting. Have anyone of you like heard of this paper? No? There was a cool, there's a channel on YouTube called 2 Minute Papers, which is really good. They talked about this like some while ago. Basically what it does is it can capture your voice profile and synthesize new sentences and dialogue out of that. So for instance,
the Norsemen considered the rainbow as a bridge over which the gods passed from Earth to their home in the sky.
So that's 4 seconds of someone talking, and then this speaker embedding was translated or drawn on top of like some text, and these are all synthesized.
Take a look at these pages for Crooked Creek Drive. There are several listings for gas station.
She'd never say this.
Here's the forecast for the next 4 days.
So you can hear that there are some like weird stuff happening. Like
here's the forecast for the next 4 days.
Next 4 days. But like you can't deny that this is really, really good.
Here's some information about the Gospel of John.
What you are lacking though is emotional weight. Like there's no emotional weight behind this. It's pretty like straightforward. So I mean, it's not going to replace Nikki's job. You're welcome. But it is a really nice tool if you have an open world with a lot of characters, and you want different voices for a crowd, for instance. Instead of going out and like capturing a million different people, you can just use the voice of people in your company and generate some stuff that doesn't need to be very like theatrical and boisterous. And yeah, it adds a lot of variation to a game, and you don't end up sounding like Bethesda, who uses like 5 voice actors for all their characters. Cool. Okay, so you're going to be interacting, inevitably reacting with. Can I make this larger again? Sorry, I don't usually use whatchamacallit. I usually use slides, and then for some reason, I thought it was a good idea to switch to Microsoft earlier this year. It wasn't. Especially since I'd automated a lot of stuff in Google Drive already. Dumb idea. Yeah. Where was I? Yeah, you're going to be interacting with a lot of these products that incorporate AI in the future, because these kind of products make your life more comfortable, easier, and more fun. Like TikTok is fun, arguably. They're going to make your work life more convenient because there are fewer considerations in order to get results that you like. And as AI becomes better and better, our role as audio producers is bound to at least pivot or change. So I want you to consider like what the essence of an audio producer is, a composer or a sound designer. We kind of set the rules and create the frameworks for how a piece of music should work and how a sound should feel. And that's something that's not likely to change. The difference is we'll instead give those rules that we want the audio to abide by to a piece of software that will take care of the rest of the work. And yeah, that's kind of like the main thing, and you will be more on the side of guiding this piece of software. And this can be like through simplified UI. I think it's going to go very much in that direction first, because like most people who aren't trained in audio can agree that audio is kind of like a complicated field, and you're going to require like years of training in order to get to a point where you can create something that you enjoy and that other people also enjoy. So I think we're first going to be able to see very simplified UIs where few actions have a lot of effect. But then we might be backtracking a little bit, realizing that we actually want some control over what's going on. Another way we can guide these pieces of software is through text. Like you've probably seen this past year with art generation models. Yeah, just being able to like write what you need and generate stuff based on like this latent-based stuff that I was talking about earlier. So we'll be more in charge of making the big decisions, right? What kind of instrumentation do we want? How should this sound feel? How much weight should it have, and how much texture? What kind of material? Oops. Cool. There are some other uses for machine learning AI that's not generative. Yeah, generative. But that tends to be the focus, right? Like that's kind of where we're at. Like, oh, now we're going to be able to generate audio and music and we're not going to have any jobs. But like, the essence of a machine learning model is prediction, right? So we can predict other things. Imagine like an open world, and we can try to predict or spend some time analyzing player behavior, and then try to predict what they're going to do next. So if we are able to predict which character the player is going to talk to next, or which area they're going to go to, based on stuff that we can't comprehend because we are not a machine, then we can start to lead into those moments even before the player gets ready to make those decisions. And that's kind of exciting. So we can kind of create like leitmotifs that enter while they're moving, well, while it's likely that we'll be moving to a specific place, and then build upon that dynamically as they're getting closer. Another way we can use machine learning is through controller data. So imagine, for example, that we want to change the music when a player is playing more aggressively. More traditionally, like if we were going to do this just by coding it, this would be very tricky. We'd have to like measure like the angle of the joystick, like how that's working, like the velocity of the joystick, like how quickly is it moving out, how far is it moving, which buttons are being pressed, like are they attacking, or are they just like trying to get through a dialogue as quickly as possible. We would have to measure the other buttons if they do anything that is remotely like aggressive, and possibly also the gyroscope, right? How is the controller tilted? And even if we could like gather all this data, we would have to translate all of that into something that corresponds to aggressive, right? That's a very, very difficult task, if not impossible. But with machine learning, what you can do instead is teach the model while you're playing aggressively, and it will learn what that means. And this means you can get, based on how you're playing with a controller, you can get that to result in an enum. What's the other term for enum? What does fmod call enums? Does anyone know? Huh? Enums. It's a label. Sorry. Yeah, it's a label. So you can get labels back from the model that can be like idle, calm, active, or aggressive, for instance. And then you can manipulate or translate that into audio how you see fit in fmod or Wise or whatever like you already do. So yeah, very cool stuff. Basically, responding to the player instead of responding to the player character. There's a more direct link. Another reason to consider this stuff, consider incorporating like advanced technology in your work, is grants. Just in Norway, we have a lot of different grants for cutting-edge technologies. Some of them are starting at, I think it's like 12 to 15 million kroner. And there are some other ones that are around the 4 million kroner mark. Of course, they do come with the caveat that you have to work with researchers for an extended period of time, and that may or may not be something you're willing to do. But maybe your employer will like you for giving like half of that to your company. Cool. Okay, so we're going to be talking a little bit about the ethics of AI. Many of you are already working with Isotope, right? And related products, maybe even Lander for like mastering. And the amount of these products on the market is just going to grow from here. And because our judicial system is not necessarily the best at keeping up with the most recent tech developments, I think it's important that we keep an open dialogue about like the nature of AI. I take it most of you are familiar with Midjourney by now? Yeah. And just in case for those who aren't, Midjourney is an implementation of a generative machine learning model that is trained on artworks and images. Along with text, actually. So you get an image, and you get the description of like what's in that image, which is necessary for the computer to understand what this is all about. You can then, because Midjourney also is really good at processing natural language, Midjourney has been developed as an app where you can generate images based on text that you write. So you can describe what you want, and Midjourney will generate that kind of image. Sometimes more successful, sometimes less successful. But I think we can still agree that it's pretty remarkable. There are currently two other actors on the market who does the same thing. They're called Stable Diffusion and DALL-E. Stable Diffusion and DALL-E are both trained on data sets of over 400 million image-text pairs. And that's a lot of data, right? How do they get this data? There's not someone who's like sitting at a computer going through like ArtStation and finding, I like this picture, I like this picture, I don't like this picture, right? The way we do this is through web crawling. Does anyone know what web crawling is? Yeah? So web crawling is, it's what it sounds like. You're making a software that crawls the web and pulls down downloads, anything that fits certain criteria. And this thing doesn't really discriminate outside of like your very narrow set of parameters, which can be like, I want images. And this thing crawls all kinds of websites and downloads whatever it can find. It can crawl like Instagram, ArtStation. It can download, if your Facebook profile pictures and albums are publicly available, not marked as private, this thing will find it and just download it, because it doesn't care what it is. It's just like, this is an image, we can use it for our data gathering. It's very easy to think that data is just like text information, right? Like, what did you buy last week through this website? Or what's your address? What's your phone number, contact info, that sort of stuff. Who's your friends on Facebook? Also data. But it's important to remember that images and audio are also a kind of data. And this kind of data is also being traded between companies all the time, whether legally or illegally, because they don't really have any control over what they're downloading. They're just sending this web crawler out on these web pages, download everything. Some of them are better than others at generating, or better than others at filtering out licensed content. Most are not, which is why you end up with like, with Midjourney, for instance, you can tell the software that you want a piece of art generated in the style of like this or this person. And the only reason it can do that is because it's seen art by that person. and knows what you mean by those words. Now, depending on how closely the art is created, knockoffs are generally kind of frowned upon. I've had some discussions with people here today yesterday regarding like whether a style can really be copyrighted, and it can't. So it's kind of like a gray area. But generally, like if it's too close to the original artwork, we call it plagiarism, right? With generated stuff, we don't really have control over how close or how far removed from original artworks it is. If it's a well-trained model, then it will avoid overfitting, which is when the output is too much like the input. But and I assume it is in the case of like Midjourney and stuff. But for some actors, it might not be, and like it would be a naive thing to think that all these three companies are the only one who's ever going to do this. So I think it's important to think about stuff like, when the time comes, is it okay for me to generate a piece of music in the style of Hans Zimmer or Elfman, right? When the time comes, is it okay for me to train my machine learning model on sound effects, all sound effects from indie games of the past 10 years, and generate sound effects similar to those in Sable? Time? Yeah, I just want to, my closing notes are just that we're kind of in the middle of like a generative audio race. And the companies that are able to do it the fastest and best in this day and age before any regulations kind of come are the ones who are going to get out on top. I don't have all the answers regarding what's ethical, what's not, but I think it's important that you think about it. And maybe we'll have some discussions like over a few beers later. Only you can decide what's too much. And with that, I say thank you so much for listening to my rambling about AI.
Thank you so much, Oliver. It's great. Do we have any questions? We have time for one question, I think. And then you'll have to catch Oliver later. Yeah. It's one question.
Thank you for the great talk. I was wondering about, since artificial intelligence is being used more and more, and like it's generating, you need a database in order for it to read the data, and there are some regulatives like GDPR and other. How are we going to actually, how do you see the data ownership being regulated? And you mentioned these crawlers that they're going through the internet and taking the data. We know the big data is a big business.
Yeah.
How do you see it evolving?
I think either we're going to see a change where we're all, basically where it's recognized that our data has value and that it's becoming less legal, or at least a legal gray zone to capture data about people, because the data that you create, I'm a big proponent of like the data that comes out of you, the data that you create they belong to you. And the reason they belong to you is because they have a lot of value for certain kinds of people in the world. And we're all kind of like the backbone of machine learning AI based on the stuff we create and put on the websites publicly. So I don't see really anything changing until this is brought up in like higher positions in society. And I think it's going to take some time for that to happen. Honestly, it should have happened 15 years ago when this all like started becoming a thing. But like they didn't know, people didn't know. Yeah, it's a very tricky situation. So I don't really have an answer to that.
Is it going to be? Are you going to be able, because of privacy issues, to like have a legal battle with people using your information?
I kind of hope so, or at least see some sort of a little bit more than just a pat on the back, like, "Hey, we're rich because of you. Thanks." But yeah, I guess time will show. Yeah, thank you, everyone.
Okay, thanks again. It's time for lunch now. So since we're a little delayed, let's be back here at 2:20. And then it's going to be a presentation and one more speaker before the GACO Awards. So see you at 2:20.